So, hello everyone, welcome back to this course. This is our first lecture in this course. This course name is Aircraft Performance. We will cover the following lectures. So, this lecture is lecture number 1, course introduction. And in lecture number 2 to 3, we will discuss the standard atmosphere. So, this course is all about how the aircraft will fly in atmosphere. What are the difficulties, challenges it will face, and how as a human we will solve this issue, how the aircraft is performing in atmosphere, what sort of range it will cover, how long it can fly, its performance at a different phases, for example takeoff, climb, cruise, loiter, landing, descent, gliding. So in all the phases how the aircraft will perform, we will cover starting from takeoff to landing. You can say this is a point 0 and this is you are taking off from 0 to 1, and here when you reach the point 1 you will reach the minimum speed to take off, and then you will rotate your aircraft and you will start climbing, and once the climb is over you can attain a certain cruise altitude, and finally you can cruise, and depending upon the requirement you can loiter the aircraft, and finally when you land your aircraft you will start descending the aircraft and you will finally land the aircraft. So you can see this is 0, 1, this is you can say 2, and this is you can 3, and this you can say 4, and this is 5, and this is 6. So 0 to 1 is a takeoff, and from 1 to 2 climb, and from 2 to 3 cruise, and 4 is loiter, and this one is descent or glide, and this is finally landing. So depending upon the requirement, so you can actually land at a different altitude, different locations, okay, and you can land on the same point depending upon the requirement. Okay, so how the aircraft will perform in a different phases, that we will discuss in this course. And even during the flight, how the aircraft is performing good in terms of maneuvering the aircraft, whether the aircraft is capable of maneuvering or not, and what are the limitations of the maneuvers, that we will discuss in this course. So it is a part of aircraft design actually. So in course introduction, so basically this is a course introduction lecture, okay, and in lecture 2 to 3 we will discuss the standard atmosphere, because finally we will fly the aircraft in atmosphere, so we should know how the aircraft is performing in atmosphere, because it will perform at a sea level in a different manner, and when it will go to the higher altitude where you will see in this lecture, the density will drop and the pressure will drop, okay, so aircraft will perform in a different fashion, okay. So these are the different types of layer. Atmospheric layer we will discuss, where you will see that temperature is decreasing or increasing in a different fashion, and pressure and density is always decreases with the altitude. That's sort of thing we'll see in the standard atmosphere lecture. And in lecture 4 we will cover the basic flight mechanics and control, because we should build the essence of what are the force is required in order to lift the vehicle, in order to move the aircraft in a forward direction, okay. So that we will discuss in the flight mechanics and control, and how will you control the aircraft when you go from the one point to another point. For example, how will you perform the takeoff, what are the control surface you will use for a takeoff, and then how we will perform the climb, what are the sort of controls is required in order to perform the climb, then finally we'll go to the cruise, where mostly you will fly, then what how will you maintain the speed and all that we will discuss in the little bit flight mechanics and control lecture here. And then we will move toward the core of the aircraft performance course. In lecture 5 to 6 we will cover the aircraft performance in cruise, because mostly the aircraft fly in a cruise regime. Okay, how much amount of fuel it is taking in order to go from point A to B, and what speed it is going, whether speed is good enough to maintain the cruise or not, and what type of power requirement is there, what sort of aerodynamic efficiency you are flying, and what is the power max condition, what is the power minimum condition, that we will discuss in the aircraft performance in cruise lecture, which is lecture 5 to 7. Okay, and how long it will cruise, that also we will discuss in this lecture. And then lecture 8 to 9, aircraft performance in climb. So we will see how the aircraft generally climb. We will discuss about the axis power, we will discuss about the flight path, we will discuss about the power plant selection based on the climb also. Okay, and in lecture 10 we will discuss the aircraft performance in descent or glide flight. So generally when you go from point A to B, you will take off and you will attain certain altitude, and then you will start flying that altitude, and when you want to land at a point B, then you have to decrease the altitude. So how the aircraft generally perform the descent, that we will discuss in a lecture number 10. And during the loiter, aircraft has to take a turn. Even if you want to go from one destination to the another, then you have to perform the takeoff, then you have to change the heading, and you have to align with the runway at the time of landing, even during the climb or attaining the particular altitude. So that time aircraft has to take a turn. So how you perform the turn, what the controls are required, and how aggressive or how well you can perform the turn. So what are the parameters associated with the turns, like load factor, speed, and all that we will discuss in the aircraft performance in turn lecture. And then in lecture number 12 we will discuss the aircraft performance in pull up and pull down, because see, when you are taking off from the ground and when you attain the takeoff speed, then you have to put the elevator back in order to rotate the craft. So some kind of pull up you will see, where you will see the flight path is changing from 0 to at a certain angle, 10 degree, 15 degree, in order to attain the climb. So we will discuss in the aircraft performance pull up. And similarly you can pull up also, and have you seen the fighter aircraft generally sub down, and it can be pull down also. So the both we will discuss the pull up and pull down maneuver in the lecture number 12. In lecture number 13 we will discuss the aircraft performance in takeoff, because we have to start from the takeoff. So how will you perform the takeoff, what are the parameters associated with the takeoff, and how can you perform the takeoff in a good way. When I say good way, then what type of wing you will design, what type of wing loading you should have in order to, and what kind of thrust to weight ratio you will have in order to reduce the runway length, and what kind of secondary control surface you will use in order to reduce the ground roll distance. So that's things we will discuss in the takeoff performance lecture. And we will also see, if you have designed this kind of graph, so at least this much runway distance is required in order to take off from the ground. Okay, and now in lecture 14 we will discuss the aircraft performance in landing, because takeoff is not the challenge, but the thing is landing is very challenging. A takeoff, generally when people say takeoff anybody can do, but there are the limited number of people in this world who can land the aircraft, and thanks to those person who can land the aircraft safely. So we will discuss how will you perform the landing, what are the runway length is required for performing the landing, and step by step procedure, how will you adopt in order to perform the smooth landing, and what are the control surface you will use in order to make a successful landing and touch the ground smoothly. That we will discuss in the lecture number 14. And will not end here. Lecture will not be limited. In extra lectures we will take some special topics. For example, we will say okay, I have designed my aircraft, I want to perform some optimal climb, so from one point to a point, or I will perform the climb like first I will climb from some altitude, then cruise, then some other, then again climb, then cruise at for some time, and then again climb. So you can see that you can climb in a step, so that we can take some special topic, and optimal climb we can see how much flight path angle is required and what are the thrust setting is required, that we will discuss in the special topics. That can be taken from takeoff also, loiter also, landing also, takeoff also, okay, and also cruise also. Any special topic can be any, see this the special topic can be taken from any aircraft flight phases, no, and later we can take more. Okay, and now we'll take some examples, and in examples we can solve the numericals, and of course discussion is not limited. So in if future we'll find something good about the aircraft and all, then we'll discuss more, and depending upon your request also we can discuss more in this course. And I believe you will enjoy in this course. So we will meet in the class, in the lesson lecture. Thank you so much.